In the first video, we went through the basics of setting up a state tree and looked at which plugins needed to be activated, how to create state trees with different schemas, how to attach them to actors or AI controllers, and a basic overview of how the editor is set up. Today we will look at state tree tasks, and these control the code that execute the logic of each of your states, therefore making it functional. In order to make it easier to understand, we will create a simple example. And as I said before, state trees are not just for AI, they can be used for anything that has a state. And in our example today, we will create a state tree that controls the different states of a door that could be on your ship, for example. And this door can have a minimum of 3 states. It could be open, it could be closed, or it could be transitioning between open and closed and vice versa. So we will begin by setting up a state tree and then looking at how we create tasks to run that tree. From our content browser, we can create a new state tree. So we can right-click, go to Artificial Intelligence, State Tree, and for our schema, we will just choose State Tree Component because this will be on an actor. We'll call that State Tree Sci-Fi Door, and we can open that. From here, we can go to the asset details, and we can change our context actor class to the actor that we will be attaching this state tree to. So that will be our BP door. That will then ensure that this actor context now points to a BP door object, which we can then access in any of our state tree tasks. State trees always begin from the root and then branch down into their child states. In our example, we will have maybe 4 states that represent when the door is closed, when it's transitioning from closed to open, when it then becomes open, and then goes from open to close. So I'll create those 4 states, and as we saw, you can simply press Add State, and that will add a child state to the root, or you can right-click and add a state in this way. So I've created a state tree with 4 tasks just by clicking on the root and pressing Add State 4 times. And then I've renamed them in the Details panel. And I've also chosen a color theme by clicking on the colors and creating a new theme so we can differentiate between closed and open logic. One thing to note is that by default, when you click on one of these add states, the type is of type state. And the type determines whether or not you can add a task to that state. So here you see that tasks are available. If I change it to group, you notice that the task option has gone. Same with linked asset, but it returns with subtree. So by default, it is state, and we will leave it at state to begin with. The way that a task is added to a state is by going to the state's details and using this tasks option, where you can press on the add new task, and you have access to a few built-in tasks. So you could click on any one, and that would add the debug task to this door closed. You can drop it down, and in this particular task, you could write a text that you wanted to show and change the color and the scale and so on. And you can also have access to parameters that are available. So you could bind it so it shows wherever your actor, which is defined by this actor context, is located. You can add as many tasks as you like to a state. So I could click on that and add a delay task. And the thing to remember is that each of these tasks on a state will run simultaneously. So they will all be entered at the same time instead of one after the other. If you wanted them to be executed one after the other, you would probably add them as child states underneath your main state and then have transition rules. When one finishes, the next one would then become active. So let's delete these 2 tasks first, and then think about what we want to happen when our door enters the door closed state. The first thing we wanted to do is to change the widget to state that it is closed. And the second thing we want it to do is to then check to see how far the player is from the door and if he is close enough to open the door. We can therefore create two tasks for this. There are two ways to create a state tree blueprint task. The first option is in your content drawer or in the content browser. You can right click, go to Blueprint class, and then just type in state tree. And you're looking for the base class, which is StateTreeTaskBlueprintBase. You can click on that and name it. The other option, and the easier one, is in the actual editor itself. You have an option to create a new task. So you can click on that and it will give you base classes to choose from. This is the default base class that you have access to and the one you're most likely to choose. So you can click on that, choose where you want to store it. I'll just call that in our tasks folder. And then you can name it as you need. So I'll call this state tree task change widget status. So that will change the title on the widget. And that will then automatically open the state tree task for you. Creating a task does not automatically add it to the tree. So if we go back to our tree, we go to our door closed state, click on the add new task. Now we should have access to that task that we've created. However, you notice we just get the name that we set and not something a bit more descriptive, and it doesn't fall under a category by default. So let's look at the state tree and see how we can change these two features. Back in our state tree task blueprint itself, if we go to the class settings, under blueprint options, we can choose to change certain details here. So if we want to change the name that's displayed in the editor UI, something more descriptive, we could change it here, set widget text. And if we want to change the category, we could say put it under a door category. We can then compile and save our task, go back to our state tree, just compile and save it again. And then under the door closed, this time when we click on add new task, we should get a new category and we get a slightly more descriptive title, set widget text. So we can click on that and now that task has been added. And it will show up under this state, set widget text, so we can identify it with a visual glance. So let's go back to our blueprint task. So by default, the blueprint graph is empty, but what you do have access to are override functions. And each of these functions allows you to hook in to the state tree and execute your logic. What we'll do is we'll override them all so that we can look to see what they do. When creating your state tree tasks, it's important to understand when these events are called, and most of them are relatively logical. So when a state is entered and it has a task on it, so when our door close state is entered and it has the change widget state on it, the first thing the state tree will do is call the event enter state on this task. On every tick while this task is active, it will call the event tick, much as you would expect. At the end, when we exit this state to go to another state, we will always get the event exit state. So these three will always happen. Now the event state completed is slightly different, for this depends on whether the state is completed or not. And that is based on whether you call finish task. And finish task can either be succeeded or failed. But if this is called, then you will get the state completed event being called. And that generally should precede the exit state. The important thing with state tree tasks to remember is that you do not have to call the finish task. And in many of your states, you actually will not call this. But if you do, then you will get an event state completed being called. You don't have to override all of these functions if you don't need to, so you can pick and choose which ones you need to override in order to execute your own particular logic in a state tree task. But as a rule, you are likely to execute your logic using the enter state and the event tick, and then maybe use the state completed or the exit state for any cleanup that you might need to perform. In this particular state task, we just want to do something simple. So we probably only need to use the event enter state. So we could delete all of these. And what we want to do is we want to get access to our BP door reference and then call a function on that door, which is update door status, which will change the text on the widget. So this means that we need to get access to that reference. And the way that we can do that is by using the variables. The variables in a state tree task allow two-way communication between the task and the state tree. They allow the state tree to send data into the task, but they also allow the task to send data back to the state tree. And when you create a variable, you can control how it functions in the state tree simply by changing the category by which it is referenced. So let's say in our task we want to get references to certain data. We want a reference to our BP door actor that this state tree is running on. We want a reference to its widget. We want to know what text to show on it. So we can start creating variables for that. So I've created the 3 variables and set the correct variable type for them. And I've left the category as being default, which is a default state. These variables will not show up on the state tree unless either they are exposed by clicking on here, or you have set them to a special category. In the first instance, if we try exposing the door, we compile and we go back to our state tree. Now we see under our set widget text task, we have the door reference shows up. There seems to be an option to pick one from the world, but this doesn't work in the current versions. However, we can go across here, which says that we can then bind the door value to another property. And the property we want to bind it to is this context actor, which is of type BP door, based on the context actor class that we set. So we could drop down here and just click on actor. That would bind this door reference to this actor reference. However, doing this on every single task can be a bit of a headache. So there is another way of doing it automatically. So if we just reset this property, so it's not bound to anything, and we go back to our state tree task, in the door reference, we can change its category. Now, by default, you only get default, but one of the special categories available is called context. And once you type in context, you can actually just remove the exposed sign there, go back to your tree. It will still show up, but this time you notice that it is automatically connected to the context actor, which is this. And this actor has the context category next to it. And it represents the context object that is being used by the state tree. And what happens is that this is automatically done as long as the reference and the type are the same. And you can't add any extra ones here yourself. So these ones are based on the schema that you choose. So for the state tree component, you just get actor as your context. For the state tree AI component, you get both the actor as a context and the AI controller as a context. So you can bind to both of those in your tasks. So this is automatically done for us, which makes it easy. The next thing we wanted to do is to bind to our door widget. So again, we could expose it and it would show up. Again, this doesn't actually do anything, but we could try to bind it here. So we could say, go down, we'll get a reference to our actor, and on our actor, there is a reference that I've created called widget door. So we could bind that in this way. But this is optional. So we can either bind it, not bind it, and it will still compile. However, if we wanted to force this to always be set by the user of our task, there is another category to be aware of, and that is called input. Again, once you set it to one of these special categories, you don't actually need to make this instance editable. Now we compile, and when we go back to our door state tree, it will now say door widget with an in category next to it. This is not bound to anything at the moment, and if we try to compile, we will get an error. It will say the input property door widget reference is expected to have a binding. So this will force us to bind it to something. And again, we can drop down, go to the actor, which is the BP door, and the BP door has a WBP door reference that I've created. So that is the input category. In terms of the text to show, again, we just want to make this instance editable, and we don't need to change its category to anything here because we just want to be able to set it. So again, that shows up as text to show. We could bind it to something if we had a reference to something, or we can just type in the text that we want to show. Closed. So that is a normal instance editable variable. And the third type, which has a category, is called an output category. So let's say we wanted to have a delay and to tell that delay how long before it completes the task. So maybe I could type in delay, set this as a float, compile it, and put this as an output. And again, we don't need to make it instance editable. So that will show up here, and this will say delay with the out category. And as you can see, we can't set it or change it. And this means that it will be set by the actual task itself. So if we created a delay task that came after it, on the delay duration, we could then bind to this output value. So I could go there, go to set widget text task, and click on delay. So whatever value we set for this in our task will now be the duration of our delay. And generally, the way that you use these categories on your variables can control how your trees play out. We can now start using these references in our enter state. So we can take our door reference, we could tell it to update the door status. The text will be the text to show that we can set from our task. We can then maybe get our door widget reference to the reference to the widget itself and make sure its visibility is set to visible. And if we wanted to set a delay, we could bring that here, say set, and maybe just pick a random float. If we didn't want any delay, then we could just finish the task at the end of the setting and say it has succeeded, and that would cause the task to complete. Whenever you call finish task, it has the potential to trigger a transition in your state tree depending on the rules that you have set. So you always have to consider whether this task needs to finish or not. And we will look at different setups where in one setup it needs to finish and in another setup it doesn't, because if it did, it would cause unexpected transitions. In this particular case, I'll actually disconnect it. This was added just as an example, so I'll remove this as well, and I will compile. As things stand, whenever any state with this task on it becomes active, it will call this function and set the text that we tell it to. We can then go back to our state tree. We've got our first task. I'll remove the delay because, again, that was just an example. And the next task that we want is the one that checks to see how far the player is from the door. So we can go to our new task, and again, we can choose the StateTreeTaskBlueprintBase. As things stand, whichever tasks that you've created also show up as potential parent tasks. And so sometimes it's worth creating your own base task where you can set up commonly used variables. But we'll stick with the blueprint base. Put that in tasks, and we'll call that state tree check player distance. The purpose of this task is to decide whether we should trigger a transition from open to close or vice versa based on the player's distance to the door. So we could perhaps go to our class settings and in the display name maybe make that a bit more clear. So trigger transition based on distance. And again, we can give it a category so it shows up under door. We can compile that. And we can go to our door closed, look for our task, say add new task, and again our trigger transition based on distance task should show up here. So we can click on that. And the way that we've set it up is that both of these tasks are on the same state, and they will both be entered simultaneously. So they will both be active at the same time. So if we go back to our task here, we know that we will need a reference to our door. So in the variables, we can again say door reference. We can set it as the correct type, so BP door, object reference. And then if we set the category as being context, it will automatically have a binding to the context actor, which should be the BP door on which the state tree is running. So that should be automatic. We then will need a function to check the distance. So we can say function check distance, and we want to check the distance between our door get distance to from one actor, and the other actor will be our player character. We then need to make a decision based on this number. So we want to check whether it's above or below a particular reference number. So we can check to see if it is less than, and we can promote this as a variable and say threshold distance. We can set this distance in the actual state tree just by exposing it, and maybe give it a default of 500. If this distance is less than or above the threshold, we should set a variable to indicate this. And there are different ways that we could do this. So we could set a Boolean, we could set an enum, but in state tree tasks, a lot of logic can be controlled using gameplay tags. So it might be worth creating a gameplay tag for this. We can press on the add to create two variables, both of which should be of type gameplay tag. One of them will be set by this function, and that will be the current door status based on the distance. And the other one will be the gameplay tag that we're looking for to trigger the transition, so we can rename them accordingly. So I've called one current door gameplay tag, and the other one is the trigger transition gameplay tag. The current door gameplay tag we will set here. So we can say set, and now we need to create some tags. So we could go down. We can create tags directly from here, just by pressing on the add, making sure that we choose the correct default gameplay tags ini, and then creating tags that will represent the different status of our door. So these tags will represent the different states: open, closed, transitioning from open to close, and from close to open. So I'll create them here just by typing in door.open. That will add one. And then we can create more from this drop-down menu again. So I've created the 4 tags. There's closed, open, and then there are the transitions, opening and closing. Now we can set the tag based on the distance. So if it's less than the threshold, the door should be opening. So we can click on that. Or we can do this as a selection. So select and do that based on the actual Boolean value. So if the Boolean value is less than the threshold, it's true. We want the door to be opening. If it is above the threshold value, then the door should be closing. And then we can connect everything up and compile. We then need to check to see whether the current door gameplay tag is equal to the trigger transition gameplay tag that we will set in the state tree. So we can go back to our event graph. We can now decide which functions we need to override in order to make these checks. So we know that enter state is only ever called once. So if we went down this route, we would then need to call a function either on a timer or repeatedly, or we could do it on the tick, where we keep calling for the check player distance and checking to see whether it meets the trigger transition gameplay tag. So if we did this on tick, the way we would do it is we would, every tick, we would call our function check distance, and then we would check to see whether the current gameplay tag was equal to the trigger tag that we'll have to set. So are these two equal? And then we could branch on this. And if they were equal, we could send a finish task back to the state tree to say that we have now met the criteria and you can transition based on that being met. So we could say finish task and say it was succeeded. If it wasn't, we do nothing and we just carry on making the checks. If we didn't want to do this on tick because we felt it was too frequent, we could override the enter state, and from the enter state we could perhaps create a timer by event. We could set how often we wanted to check it. So again, that could even be a parameter set by the state tree, a 0.2 seconds. We could loop it, and then we could create an event which is check for trigger. From here, we could call our check distance, and again do the same logic that we had at this point. So we can copy and paste that. If it matches, we finish the task. If it doesn't, this timer will keep running every 0.2 seconds. Now, what happens when we do finish the task? Will this timer stop? Generally, it should stop when the task is over, but this would be one of those situations where you might want to do some cleanup at the end. So you could promote this to a variable. Just call that our timer. And then you could override the state completed and then tell the timer to invalidate itself. So get timer and just say invalidate, clear and invalidate timer handle. So that would prevent any risk of it being triggered again once it has met the criteria. When you hover over the actual state completed node, you see that it does tell you when the state completed will be called. And one of the points it makes is that it would not be called if a conditional transition takes place. So if an external event triggers a change, this would not be called. So again, you might want to override the exit state to make sure that any cleanup that needs to be done would actually take place. And as I said, timers generally do finish when the task is ended, but sometimes if you're using gameplay tasks, you might want to ensure that that task, if it's latent, is actually ended on the exit state so it doesn't continue to run in the background. We can decide which logic we want to go with because we don't want to do both. So we could even just combine the two. We could do the timer to check for the trigger, but instead of doing this here, we can just allow that check to take place on the event tick. And that would work. The one thing we need to do is to ensure that this trigger transition is actually set, so we're comparing it to the correct gameplay tag. We can simply do this by making the trigger transition gameplay tag instance editable. We could force it to be an input category, but then we would have to create a parameter for it to bind to. So this would be the simplest approach in this case. So we can compile, go to our state tree, and our door closed state. We should have everything set up. So the context actor is automatic. The reference has been set as an input. We've set the closed text to show. This output we're not using, it was just for an example. But on the trigger transition, we can now confirm that the actor has been set as a context actor. The threshold distance we can leave at 500 or change it. And we can set our trigger transition tag, the one that we are looking for. And that is, if it is closed, we're looking for the opening tag. So we want to see whether it should be opening. And we can compile. In our setup, the set widget text will start and then just continue running. There is no finish task on it. It is the trigger transition that will trigger the finish task node when it has met the criteria. And once it has done that, we can then set some transition rules. So what we want is perhaps when it meets the onState completed. An onState completed can be triggered either when the finished task is succeeded or failed. So you can separate them. You could say onState completed, that triggers on either, or you can set them individually. If it succeeds, do this. If it fails, do that. But this is the most commonest one that you will probably use. And I think in our logic, this would cover most scenarios. Once that is triggered, we can tell it to transition. We can pick simple things like just go to the next state, which based on our setup would be the open door, or we can specifically set it as being trigger the open door state next. And that makes it clear. So door closed can transition to open door, and it will be based on state completed, i.e. receiving the finished task event. The door open state is exactly the same as a door closed, except that it is the opposite in some ways. So let's try setting this up, but slightly differently. Instead of putting everything on the same state, we could create child states. So add child state, and that state might be set open text, and create another child state, and this would be check if should close door. On the set open state, we could choose the same task, which was our set widget text, and we can say open. We can choose the widget reference, WBP door, and the context is automatically set. On the check if should close door, we would use the same state. So that would be the trigger transition based on distance. We can keep the same distance or maybe change that. And the tag that we're looking for here would be the closing. So should we be in closing transition? And again, we can compile. Now, the only issue here is that this will not work as it is set up, because though when we enter this door open state, it will automatically, based on the selection behavior, try to select its children in order. So it will go to the set open text. We would then have to finish this task in order to trigger a transition to go to the next state. However, in our current setup, there is no finish state option. So we would either have to rewrite this, or we could even just put in another Boolean value just to test it out. For instance, create a Boolean should finish task. And we can expose that to be set in the state tree. And then we can just branch on this. You could say branch. And if it is true, we can say finish state or finish task and succeed it. So by default, it will be false. Back in our door open state on the set open, we want this to finish the task. Once it finishes the task, we can set a transition on state completed, go to the check if should close door. And the check if should close door, when it receives its state completed, it will transition to close door. So this is a different way of setting up the same thing here. The only difference is that we do need to finish this task so that it then moves on to the next one. Whereas in this setup, both of these can run simultaneously, and it is the trigger transition based on distance that will ultimately send the finish task event to move to the open door state. This door open state doesn't have any tasks on it, even though it could, which means that we could maybe even change it from a state to just being a group. So it is a group that contains states that can be active, but under the details panel for the group, you notice that there is no selection behavior by default. So we should explicitly set a transition rule so it enters the correct child state. Using groups is just another way of organizing your logic in the state tree. The next thing we need to do is our final task, and that is to play the animations that transition from open to close and vice versa. So we can create a new task, and again we will choose our StateTreeTaskBlueprintBase. We can go to Tasks folder and maybe call this our StateTreeTask Transition. That will open up automatically. So we can give it a blueprint display name. I've called it Play Transition Animation, and the category again we can put under Door. So again, we will need to get access to some variables. So we'll need our BP door. So we can say door reference, choose BP door, object reference, and set the category to context. We can then override the state. So we want to override the enter state. In order to play the animation, we will need to have a reference to what animation to play. So we can create another variable, the animation to play, and we could set this either as montages or as animation sequences. I think I'll go for an animation sequence because that's what I've got available. We can compile. And this animation sequence, we do want it to always be valid. So what we'll do is, this one will actually put as input, and then we can learn how to use parameters on the state tree. And basically, once we enter the state, we'll get our door reference. We'll need to play the animation on the skeletal mesh. So if we type in play animation, we should get the sci-fi door, which is the name of the skeletal mesh. And we can put that and link that together. And this we can set as the variable that we will send in. We can then put in a delay based on the length of the animation. So we can say get play length and use that as our delay. So we'll delay for that length of time, and then we can call the finish task. So this will finish it as succeeded. If you unclick it, that would be failed. So that is succeeded. And that is our state tree task for the transition. So we can go back to our state tree itself, and on the open door transition, we can give it a task. And that task will be play transition animation. And we can choose the animation to play here. So we need to find a parameter that we can bind to. The easiest way might be if we create some parameters here, and then we can set them in the state tree in our actual actor itself. So the first parameter, we can set that as an animation sequence, object reference, and we can rename it. So I've created two parameters, one opening door animation sequence, one closing door. We can set default values here if we want to, or we can actually set them in our BP door asset itself. So I'll leave these empty here at the moment, but we can now connect the animation to play for the opening door to our parameters and opening door animation. We also want to change the text on the widget, so we can add that task as well, our set widget task. We can find our actors widget reference, and the text to show will be here, opening. And this we will leave this as false or should finish task. We compile, that should compile okay. The order in which we do this doesn't necessarily matter, just because they will both be executed simultaneously, but we can move it, change the order in the actual editor itself, so it's more logical for us. On the closed door, we'll add the same tasks, but we'll do it as child tasks. So set closing text, and the task we will give that is the set widget text, and this will be closing. And on this one, we do want it to finish the task so that it moves on to the next state. And again, we need to give it the correct widget reference. We can then tell the transition on state completed once we've added the other state. So add another child state, and that will be play closing door animation. So we can tell this when it's completed to go to the play closing door animation, or even just the next state. So that should automatically move to whatever the next state is. And the next state will have the task play transition animation, and the context actor is bind automatically, and the animation we'll get from our parameters list, which is the closing door animation. So we compile, everything compiles fine. I can see that we've not set the transition on the open door correctly, so we should add the transition on state completed. So when the animation is played, we want it to transition to the door is open state. And the other thing we haven't done is, if we look at the group here, door open and closed door. So closed door is a state with a selection behavior, select children in order. And you see this icon where it points down. So this, when entered, would automatically go to the set closing text state. The door open is a group. And as I said earlier, groups do not automatically move to their children states. So as you can see, it just goes across. The icon is different, suggesting that it will either just get stuck here, or generally what happens in state trees is if it cannot complete the transition, it will automatically return back to the root, in which case it would then go to the door closed and restart from there. What we can do is, it's worth sometimes finding some bugs in your state trees just so that you can see how to fix them. I suspect this will probably end up causing us problems, and not setting these parameters may also cause problems just because there may be some issues in the state tree itself rather than in our logic. But let's assume that the rest of all this is actually working the way that we want it to. And from what I can see, that is the case. What we now need to do is to go to our actual BP door. And from here, we can now add the state tree component. So we say add, and we add the state tree. We can then pick our state tree, which is the state tree sci-fi door. And this gives us the option to override those parameters. Let's click on both, and we should be able to set them here as long as there are no bugs in state trees. So opening door will be door opening, closing door will be door closing. The other thing is state trees, as we said, can start their logic automatically. However, in our state tree, many of our tasks need a reference to this BP door widget. So instead of starting it automatically, it might be better to make sure that the widget reference is set, and drag this out and say start logic. Because if we don't, we might get an error saying that we don't have a reference at the very start of the state tree. So we compile that, and let's see whether things are working or where they go wrong. So to begin with, there is nothing on the door itself. When I press play, it shows that it's in the closed state. Now when I go here, we're getting an issue here, so things aren't working. If I just escape, we see that we've got lots of errors. And the errors all seem to be related to the animation to play. So I think this is a bug in state trees as they stand, in that setting the parameters here does not seem to override the lack of parameters here. So if we actually set them over on this side, door opening, door closing, we compile, and we play, and then we go towards the door. So we get the opening, but as you can see, it's now just going back down to the root and repeating all the issues again. But there are no errors in terms of references. And I think this is going to be an error because of our door group. So we do have a debugger available. And when you open the debugger window, it shows down here. And then you can just play the game, launch it from here. So what we see is it's closed to begin with. We go towards the door, it opens, but then it keeps going back to the root. So we'd see here that we are opening, going to the root, and you can cycle through the frames. So at some point you might notice that there is actually an error that has taken place. In other words, the transition that we're looking for or expecting isn't happening. So here you can see that there was an error, could not trigger completion transition. So it's jumped back to the root state. So once the door is opened, instead of going to the door open, there is a transition issue here. It's going back to the root. So if we go to our door open group and we just give it a transition. So click on transition and we'll just say on state completed, transition to set open text or go to next state. We'll define that as set open text. Now when we play again, The door is closed to begin with. We get the opening animation. Now it's open. It stays open until we move away. We get the closing, and then it's closed. And each time we go back and meet the threshold, opens, opening, open, remains open when we're within the range. And now we get the closing, and it's closed. So our state tree is working. The one thing to be aware of with state trees is to do with the parent-child relationship, where essentially when a new child becomes active, so too do its parents. So for instance, when we transition to this closed door state here, so enter state, closed door activates its child state set closing text. And you notice here, when set closing text is entered, that the new active states become the root, closed door, and set closing text. So the root, closed door, and set closing text all become active. That means any tasks which are running on this state, its parent state, or its parent state will receive the enter state event. And that will happen each time it changes. Then when we go from set closing text to play closing door, on this transition, you notice that the state completed is called not just on set closing text, but also on closed door and root. So when this closes or completes, this completes and this completes. Then it transitions down to play closing door. And when that happens, down here you can see that the new active states again become root, closed door, and play closing door animation this time. So if you've got tasks which are running on the parent states, each time a new child is selected, the parent state task will get the enter state event, and that might not be something that you actually want. So if you go to your actual tasks, there is a way to deal with that issue. In your class defaults for a state tree task, on the default there is this option called should reset or should state change on reselect. By default it is on, so every time this state becomes active, it receives the event enter state. But that might not be something that you want for the parent states. So if you untick this, then the enter state will only get called on the first time it is selected. The other option is to take advantage of this transition structure. So this sends us some information which we can break. And from here you can actually test to see the change type. So this is either sustained if the current state was reselected, or it is changed if the state was just activated. So you can decide whether you want to run the event enter state logic or not. So you can just do an equal and check to see which one of these it is. And when you hover over it, it tells you what the two mean. The reason why you might want to do that is if this state was continuously being reselected, then all of this logic would keep getting played again. And if you were doing a lot of things with timers and all the rest, they would be restarted. So it's worth being aware of that particular option in the defaults. State trees also have the concept of global tasks, as you can see over here. And global tasks are just normal tasks that can be added. The difference is that the global tasks are not tied to any particular state. So they will start running when the state tree begins, and they can continue being active throughout all the state changes. That means that you can use the global task to set parameters, or to bind to event dispatchers, or to trigger changes in the state tree, depending on external factors. And these global tasks should start ticking before the root begins to tick. So for instance, I've just added a debug task to a global task and added a debug to the root. And as you can see here, the tick on the global task debug precedes the debug task on the root. So this can be a good place to set up your parameters as well, as they will then become available when the actual root is activated. And global tasks, there is no concept of triggering transitions on them like there are on tasks in the state tree states. themselves. So we've gone through state tree tasks today, and we've covered the class settings, the class defaults, looked at the different overrides and what they mean, and how to set variables and set the correct categories on them. I've done more in-depth videos on variables and parameters, how to use the property reference node. So I will link to that. We've also created a state tree that is functioning to open and close a door, looked at groups and states and how to set up different logic. We've also had a quick look at how we can use the debugger to identify any bugs. In the next videos, we should look at how enter conditions operate, as well as how transitions can be used a bit more in depth. In other words, how the other options work.